In this section, we'll discuss the principle of balance, center of gravity, load centers, capacity plate information, the stability triangle, cause of tip-overs, the effect of attachments on a lift truck. As a lift truck operator, your main goal is to operate your machine safely and with precision. In order to do this, you must always have your truck under complete control, and maintaining control means understanding the principle of balance. The stability of a lift truck is based on the principle of balance. We are all familiar with the teeter-totter. To balance the teeter-totter, you have to have equal weight on either side of the center pivot point or fulcrum for the teeter-totter to balance. For lift trucks, the weight of the load on one side of the load wheels must be balanced by the truck's weight on the other side. The truck's offsetting weight includes the battery, motors, and frame. The truck's load wheels act as a fulcrum or pivot point between the load and the weight of the truck. Now let's consider the elements of a load. Every load has a center of gravity. The center of gravity is defined as the location within an object around which all weight is evenly distributed. And this definition remains true regardless of the object's shape. These three loads weigh the same, but because they have different shapes, they have different centers of gravity. You will often hear the term load center. The load center is defined as the distance from the face of the forks to the load center of gravity. Most lift trucks are rated to lift a specific weight to a specific height at a given load center, usually 24 inches. That means the load's center of gravity must be 24 inches or less from the face of the forks in order for the truck to lift its rated capacity. The lift truck has its own center of gravity. Since a lift truck travels forward and in reverse, lifts, lowers, tilts, reaches, and retracts, its center of gravity moves. The lift truck's center of gravity moves forward as the mast tilts forward and moves back as the mast is tilted back. The center of gravity moves up as the mast is raised and moves down as the mast is lowered. Since the mast does not tilt on the pantograph reach truck, the center of gravity moves forward as the reach mechanism is extended and moves back as the reach mechanism is retracted. When a lift truck picks up a load, the center of gravity of the truck and the center of gravity of the load will produce a combined center of gravity. Lift truck balance and stability are affected by both static conditions and dynamic forces. Static conditions include load characteristics such as size, shape, and position on the forks. The dynamic forces created by motion include acceleration, speed, braking, lifting, lowering, tilting, and turning. Other dynamic forces include the height to which a load is raised and the amount of reach forward and backward. In addition, operating a vehicle on an uneven surface like a ramp changes the combined center of gravity, affecting its stability. By law, every lift truck must have a capacity plate. The capacity plate contains information that is crucial to the safe operation of the lift truck. This information includes the load center, the load weight that the vehicle can safely handle, and the height the load can be lifted with the mast vertical. The total weight of the load must also include the pallet, container, or the device holding the load. Another piece of information on the capacity plate is the offset dimension. Offset is the distance a load can move across the mast. The typical movement of a side shift carriage is 4 inches either side of center, so an offset dimension will not appear on the capacity plate. If a truck is equipped with an attachment that is more than 4 inches of movement either side of center, the capacity plate will show how many inches the load can travel horizontally and the net capacity of the truck. Other information includes the model number, serial number, nominal battery voltage, approximate truck weight without battery, and battery weight, minimum and maximum. It also shows the lifting capacity, load center, and lift height with mast vertical. In this example, the load center is 24 inches, the lifting capacity is 4,000 pounds to 188 inches with the mast vertical. Because truck capacity is dependent on load center and lift height, whenever the load center and/or lift height is increased, the amount of weight that can safely be lifted must be decreased. Sometimes, lift trucks are equipped with attachments other than forks. Attachments such as clamps or side shifters actually reduce capacity in two ways. First, the attachment can often lengthen the load center, thus reducing its load lifting ability. Second, the attachment's own weight reduces the lift truck's capacity. You should therefore think of a truck with an attachment as already partially loaded. Modifications and additions which affect capacity and safe operation shall not be performed by the customer or user without manufacturer's prior written approval. Capacity, operation, and maintenance instruction plates, tags, or decals shall be changed accordingly. The next part of your training should include an understanding of how lift truck stability is maintained. A typical lift truck has a 3-point suspension, the two drive wheels, and the center point of the rear axle. In the case of reach trucks and order pickers with base legs or outriggers, the suspension points are the two load wheels and the drive tire. This forms the stability triangle base. With the added dimension of lift height, a stability pyramid is formed. In order for a lift truck to remain upright, the combined center of gravity must remain inside this pyramid. If you allow the center of gravity to shift outside the pyramid, an imbalance will occur, resulting in loss of steering control, loss of traction, increased stopping distance, unstable loads, or the potential for a tip-over. About 25% of all fatalities involving lift trucks occur when the truck tips over. To avoid tip-overs, it will help you to understand the principle of stability. Because the center of gravity of an object is not fixed, it can change when acted upon by certain forces. The combined center of gravity, which is created by a truck and its load, tends to move towards the edge of the stability pyramid under certain circumstances. Lateral stability can be lost when the center of gravity moves too far to either side of and crosses over the stability pyramid, causing the lift truck to tip sideways. Longitudinal stability can be lost when the center of gravity moves too far forward and crosses over the stability pyramid, causing the lift truck to tip forward. Sharp turns, braking abruptly, excessive speed, contact with an obstruction, traveling with a load too high and or tilted past the vertical position, raised mast, and traveling over wet or uneven surfaces can result in loss of stability. In addition, unstable loads or driving on ramps can affect stability and result in a tip-over. Avoid these situations and never lift or travel with a load that is greater than the rated capacity of your truck. Remember, it is your responsibility to maintain the center of gravity within the confines of the stability pyramid. By keeping your maneuvers smooth and slow, you will minimize the chances of losing stability and creating a tip-over. This is the end of Section 2. Please review the information you have been given and complete Section 2 in your workbook. And when you are done, resume your training with Section 3 of this program.